In this video, I am going to discuss IUPAC nomenclature rules. There are various rules. All those rules again further divided into sub rules. Let us take the first rule, that is the longest chain rule. So what is meant by longest chain? How to select the longest chain? There are four sub rules in this. The first one says carbon chain with the maximum number of carbon atoms should be selected. So before naming the organic compound, we have to select the longest chain, the chain of carbons, the chain with maximum number of carbon atoms. And here if you see, there is no functional group, only it is alkane hydrocarbon. And here the possibilities: this is one terminal carbon, this is one terminal carbon, this is another terminal carbon. The possibility, if you take the chain like this, 1 2 3 4 5 carbon chain, 1 2 3 4 5 6 carbon chain, 1 2 3 4 carbon chain. So obviously, since we need to select the longest chain, this will be the longest carbon chain. So this chain has totally 1 2 3 4 5 and 6 carbons chain. And let us take the next example. Here also we don't have any functional group, it is also alkane. So the terminal carbon, so this is one terminal carbon, this is second terminal carbon, and this is one more terminal carbon. Let us take the possibilities: 1 2 3 4 5 6 7 8. So one possibility, that is 8 carbon chain. So here 1 2 3 4 5 6 7 8. So this is also 8 carbon chain, 8 carbon chain. One more possibility: 1 2 3 4 5 6 7 8 9 carbons. So 1 2 3 4 5 6 7 8 9. Since we have to select a longest carbon chain, so this will be the longest carbon chain of this particular compound. Totally there are 9 carbons. And let us take one more example. This is the example, again there is no functional group. So this is the terminal carbon, this is terminal carbon, this is another terminal carbon. Let us take the possibilities: 1 2 3 4 5 6 carbon chain. One is 6 carbons, and here 1 2 3 4 5 6 7 carbon chain. One possibility is a 7 carbon chain, and here 1 2 3 4 5 6, again it is a 6 carbon chain. So longest carbon chain: 1 2 3 4 5 6 and 7. So this is the longest carbon chain, 7 carbon chain. So one more example. So this is the given compound. This is one terminal carbon, this is one terminal carbon, this is another terminal carbon, and of course this is also terminal. And the longest carbon chain, you can see from this we can take 1 2 3 4 5 6 7 8. So that is 8 carbon chain. So if you take the other possibilities, definitely you will get less than 8. 1 2 3 4 5 6, 6 carbon chain. 1 2 3 4 5 6, 6 carbon chain. 1 2 3 4 5 carbon chain. 1 2 3 4 5 6 7 carbon chain. So here the maximum number of carbon atoms present in this chain, so this is the longest chain. And let us take one more example here. So 1 2 3 4 5 6 7 8 9 and 10 carbons. If you take the chain like that, 10 carbons you are getting. And here this is 2 methyl groups it is having. So here one methyl group, this side one methyl group. So let me take 1 2 3 4 5 6 7 8 9 carbons. 1 2 3 4 5 6 carbons. 1 2 3 4 5 6 7 carbons. So obviously this will be the longest carbon chain. So the longest carbon chain, so if you take one more possibility, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this chain has 10 carbon atoms, and this is about the longest carbon chain. Carbon chain with maximum number of carbon atoms should be selected. And the second sub rule, if a functional group is present, longest possible chain, the longest possible chain with the functional group carbon should be selected. So here we have to take the functional group carbon in the longest chain. Functional group carbon should be present in the longest carbon chain. So here we have a functional group OH. Of course, chlorine is also functional group, but OH gets more priority. Another rule we have, that is a priority rule. So this OH containing carbon should be present in the longest chain. So you have to take like this: 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. So the longest carbon chain will be like this. So here this is the longest carbon chain. Functional group carbon should be in the longest chain. That is the second sub rule. Longest possible chain with maximum number of functional groups. So if the compound contains more than one functional group, we have to select the longest chain in such a way that maximum number of functional groups should be present in the longest chain. For example, here I am taking, here it is a COOH, and here this is also COOH, and we have like this. And if you take the chain like this, 1, 2, 3, 4, 5, 6, 7 carbons you are getting, but this is not coming into the longest chain. So 1, 2, 3, 4, 5. So we have to select the longest chain in such a way that the maximum number of functional group carbons should be in the longest chain. So this is the correct selection. One more sub rule we have in this: if two or more chains with equal length are possible, if two or more chains with equal length of carbon chain is the same, but two or three possibilities, in that situation we have to take the chain with the maximum number of substituents or maximum number of branches. Instead of reading the rule again and again, let us apply this. For example, here I am taking, this is the first possibility. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is a 10 carbon chain, and there are two branches. This is one branch, this is another branch. So that is a 10 carbon chain with the two branches. 10 carbon chain, that is with the two branches. Let us take another possibility. So here this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon. So let us take one more possibility here. This is the chain, and in this again we have 10 carbon atoms: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it has 1, 2, and 3. So we have a 10 carbon chain with 3 branches. This is a 10 carbon chain with 3 branches. If you take any other possibility, you may not get maximum number of carbon atoms, but still we have to check 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So this is 10 carbon chain with the two branches we are getting. This is another 10 carbon chain. But here we have 1, 2, 3 branches. Therefore, the correct longest chain will be like this. This is the correct longest chain. So let us take one more example here. So this is the compound 1, 2, 3, 4, 5, 6, 7 carbons. So that is a 7 carbon chain. This is one branch, this is one branch, this is another branch. So there are 3 branches. So there are 3 branches. So 1, 2, 3, 4, 5, 6, 7 carbons, and these are the 3 branches. 1, 2, 3, 4, 5, 6, 7. In that situation, this is one branch, this is another branch that is having only 2 branches. So 1, 2, 3, 4, 5, 6, 7. This is the longest carbon chain, but this is one branch, this is another branch, only two branches we are getting. Therefore, this is the longest carbon chain. So 1, 2, 3, 4, 5, 6, 7 carbon chain. So this is your principal carbon chain, branch 1, branch 2, branch 3. So these are the 4 rules, 4 sub rules in longest chain, longest carbon chain. Second rule is least locant rule. It is also divided into 4 sub rules for the sake of convenience. In this, the first sub rule says numbering of a carbon chain is done in such a way that functional group carbon gets the lowest possible number or high priority. Both are one and same. So in the first rule, we have to select the longest chain. After completion of selecting the longest chain, numbering should be done from one terminal. The carbon chain has 2 terminals, either from left terminal or right terminal, whatever it may be the direction. The numbers have to be allotted to the carbons of longest chain. While giving numbers, we have to see that the functional group carbon should get the highest possible priority, otherwise lowest possible number. So in this, very clear, this is the longest chain, no doubt about it. So this is the longest carbon chain, and if you give numbering from left terminal, you are going to get the priorities like this. So this is 1, 2, 3, 4, 5, 6 and 7. Here this is one alcohol functional group, this is another alcohol functional group, and alcohols are receiving 2, 4 positions, 2, 4. If you give numbering from right side, 1, 2, 3, 4, 5, 6. So 4, 6. So least locant rule says that, so here 2 we have, 4 we have. So without any hesitation, we have to say this is correct numbering and this is wrong numbering, and this is about the first sub rule in least locant rule. Numbering is done in such a way that functional group carbon gets the lowest possible number, but numbering should be started from terminal carbon. That is the most important thing. Next one is, if a functional group is absent, then the priority should be given to substituent. So substituent carbon should receive the least possible number, but at the same thing, numbering should be started from terminal. So here, this is the carbon chain. So here, if you see 1, 2, 3, 4, 5, 5 carbons for the sake of convenience. So let me write like this. This is the bond line notation, and here we have bromine. And the longest possible chain So this will be the longest possible chain. There is only one possibility, but numbering should be from right side: 1, 2, 3, 4, 5. And in this situation, bromine containing carbon is getting second number. If you give numbering from left side 1, 2, 3, 4, so the possibilities, one is 2, another one is 4. According to least locant rule, this is correct, this is wrong. So this is about second sub rule in least locant rule. The next one, if location of first branch is same, if location of first branch is same, then consider the location of second branch. If that is also same, then consider third branch. So let us understand this. So without any hesitation, this is the longest carbon chain, and the first priority should be given to functional group. So you give numbering from left side 1, 2, 3. Functional group is receiving third priority. 1, 2, 3. So that means from both the sides, from either side, functional group is getting same priority. So that is the third priority. So whenever functional group is receiving the same priority, then we have to consider the substituents. The substituents here, methyl group we have, methyl group we have, methyl group we have. If you give numbering from right side 1, 2, 3, 4, this is at a second position, this is at a second position, this is at a fourth position, that means it will be like 2 comma 2 comma 4. So this is at a second position, this is at a second position, this is at a fourth position when you start numbering from right side. If you give numbering from left side, it would be 1, 2. So this is a second and this is fourth. That means you will be getting 2 comma 4 comma 4. So when numbering is done from right side, the branches are receiving the locants like 2, 2, 4. If you give numbering from left side, the branches are receiving the numbers 2, 4, 4. So this is 2, this is 2. So we cannot decide. But here the second locant is 2, but here the second locant is 4. So if location of first branch is same, then consider the location of second branch. If this is also same, then we have to consider third, but here at a second branch only we are getting the difference. Therefore this is wrong, this is correct. Hence the numbering of this particular compound will be like this. So this is 1, 2, 3, 4, 5. And another important point here, because this particular point here I am discussing because many students are committing mistakes here. The two carbons of double bond and triple bond should get two adjacent numbers. So let us understand this. Two carbons of double bond or triple bond should get two adjacent numbers. So what is this rule? For example, here we have a double bond like this, and here I am taking CH3 group. You have to follow the rules, no doubt about it. If you start numbering from this side, this should get a second priority. If you start numbering from this side, this should get immediate priority. So this particular rule I have taken based on the mistakes done by the previous students. See, what they did is they started from this, and however double bond is the functional group, it receives the first priority. Then they thought to consider branch like methyl group. That is wrong. The two carbons of double bond should always get two adjacent numbers. Here we have the functional group and this is the branch. Without any hesitation, this is the longest chain rule, no doubt about it. In this longest chain, if you start numbering from this 1, 2, 3, so that is one possibility. And if you start from this 1, 2, 3, 4, 5, 6, so however functional group carbon, that is double bonded carbon, is getting first priority, here also first priority. When functional group is getting same priority, we have to consider the branch. Here the branch is getting third priority, here the branch is getting sixth priority, therefore this is wrong. This is wrong. So let me take one more example like this. So earlier the students committed a mistake like this. So they were thinking like 1, 2, 3, 4, 5, 6, 7 carbons. This is 7 carbons. However, functional group is present in the longest chain. Both the carbons of double bond, both the carbons of triple bond should be present in the same longest chain. So this is definitely the wrong one. So this is double bond, both the carbons must be in the longest chain. So here this is 1, this is 2, this is 3, 4, 5, 6. So you may be getting extra carbons like this, for example. So in that situation it will become like a 7 and 8. So you may have extra carbon like this, but still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons, but carbon of functional group is not coming into the longest chain. So if you select the longest chain like this, definitely that is the wrong. So this is the longest carbon chain, and the numbering should be started from this end, and this will be branch. Next rule is alphabetization. So this alphabetization rule is also further divided into various subrules. Let us discuss the first subrule, that is, it is used for numbering chain when least locant rule is unable to decide the same. So let us understand this. In order to understand this particular rule, here I am taking, for example, so this is the organic compound, and no doubt in this is the functional group should receive more priority, least number. So you start numbering either from left side or from right side. OH receives the same priority, that is the third priority. Either from left side or from right side, OH receives the same priority, that is 3. Whenever functional group receives same priority from both the ends, one should consider other substituents, other branches. So here we have bromine, here we have chlorine. If you give numbering from left side, you will be getting bromine carbon as 2, chlorine carbon as 4. That is, locants are 2 comma 4. 2 comma 4 are the locations of branches. Even if you give numbering from right side, chlorine carbon is 2 and bromine carbon is 4. So functional group is receiving 3 and branches are receiving 2 comma 4. That means least locant rule is unable to decide the actual numbering. But we cannot say you can go for numbering from either side, but definitely that is wrong. In that situation, when least locant rule is unable to decide the actual numbering, in that situation you have to go for alphabetization. So however functional group receives the same order of priority. So bromine, its spelling begins with B. Chlorine, its spelling begins with C. In alphabetization rule, in alphabetical order, B comes first. Therefore, the actual numbering of this particular compound is this one. This is the numbering, and this is the importance of this rule. So this is about the first sub rule in alphabetization. Next one, we also use alphabetization in listing different substituents. Different substituents are listed in alphabetical order. For example, here I am taking a carbon chain like this. Here I am taking functional group, and here this is chlorine. Here I am taking bromine, and here one more branch I am taking, that is methyl. So this is the given organic compound. No doubt OH is a functional group. This will receive first priority 1, 2, 3, 4, 5 like this. And in this, so here we have one branch, here one branch, here also one branch. While indicating the names of these branches, that is prefixes, we should indicate the names according to alphabetical order. So bromine comes first, after that chlorine, chloro, next methyl, M. So different substituents are listed in alphabetical order: bromo, chloro, methyl. This is the another case, another situation where alphabetization rule is used. And most importantly, the prefixes iso and neo are considered, iso and neo are considered in alphabetization. So whenever you are writing isopropyl group, you have to consider I of iso. These are non-hyphenated prefixes, but hyphenated prefixes secondary and tertiary are not considered in alphabetization. For example, so here this is the compound we are taking. Here we have a COOH. Here also let me take a COOH. And here I am taking one isopropyl group, and here I am taking secondary butyl group. So how to identify alkyl groups? In one of the previous videos clearly I discussed. So here this is isopropyl group and this is a secondary butyl group. So in case of isopropyl, so here it is non-hyphenated prefix. Therefore, in alphabetization we have to consider I, isopropyl I. But this particular group is a secondary butyl. In case of secondary butyl, we don't write the complete spelling of secondary. We write SEC, SEC, secondary butyl, secondary butyl. So we have to take this S. We secondary butyl. So we should not consider this secondary. This is a hyphenated prefix. We have to consider only B. So this is about isoneo consideration. Secondary and tertiary, these hyphenated prefixes are not considered. And one more point, that is the numerical prefixes di, tri, tetra, these are not considered in alphabetization. That is not the actual name of the substituent. Numerical prefixes di and tri, these are used only to indicate the repetition. For example, we have compound like this, and here this is bromine, this is bromine, and here this is chlorine. So here we have one bromine, here also we have one bromine. Due to the presence of two bromines, generally we say dibromo, and here this is chloro, so that is C. But this numerical prefix should not be considered. We have to consider only B of bromo, C of chloro. So these are the four sub rules of alphabetization. Now the last one, that is some miscellaneous rules. In this, most importantly, when the organic compound contains more than one functional group, then you have to use this sequence rule. According to IUPAC, carboxylic acid always gets first priority, then sulfonic acid, ester, acid halide, amide, cyanide, nitrile functional group, aldehyde, ketone, alcohol, amine, alkene, and alkyne. So this priority order, priority sequence is very much important. Here, for example, if organic compound contains alcohol, and ketone. Then according to IUPAC, you can see this is the position of ketone and this is the position of alcohol. Ketone gets more priority. Therefore, this will be your first grade functional group. This will be your second grade functional group. For first grade functional group, we use secondary suffix. For second grade functional group, we use secondary prefix. Prefix name will be used. So this is a very important order. So based on IUPAC sequence rule, we have to select the first grade functional group. Remaining all functional groups will be second grade and they receive substituent treatment. Substituent treatment. For example, if you have something like a carboxylic acid, ketone, alcohol, amine, like this. So this will be first grade functional group and remaining ketone, alcohol and amine are second grade functional groups. They will receive prefix treatment, substituent treatment. They will receive a prefix name. So this is about the IUPAC sequence rule. That order should be remembered. Next one, the very important one, while naming esters. While naming esters, irrespective of alphabetical order, alkyl group attached to oxygen should be indicated first. So let me explain the rule. So here this is ester functional group. Here I am taking some bromine. Here I am taking chlorine, like this. So while naming esters, of course, this is your longest chain. 1, 2, 3, 4, 5. And here, this is one substituent or branch attached to oxygen but not a carbon chain. This is one branch or substituent attached to carbon chain, attached to carbon chain. If this is also attached to carbon chain, then I would have taken alphabetical order for sure. But this is attached to oxygen. So while naming esters, the alkyl group attached to oxygen should be indicated first, irrespective of alphabetical order. The name begins with ethyl. After that, whatever the branches you have on carbon chain, they must be arranged according to alphabetical order. Alphabetical order is applied only for bromine and chlorine, but ethyl group should be indicated first. The name of this ester begins with ethyl. So this is a very important rule. And another important point, that is order of priority. If you see secondary suffix greater than primary suffix greater than secondary prefix. So what is the significance of this? If you see, for example, I am taking, this is a cyclic compound, here OH, here I am taking double bond and here I am taking some bromine. And here it is very clear, this is the first grade, this is the functional group alcohol. Of course, this is also functional group, but for double bond, it is a primary suffix. So in this example, so here this OH is the first grade functional group, therefore we use secondary suffix. And here this is CC double bond, here we use primary suffix, and this is branch, here we use secondary prefix. Without any hesitation, the numbering will be started from this position. Then you may have a confusion whether you have to move in clockwise direction or anti-clockwise direction, because if you move in clockwise direction, this is receiving 2, this is receiving 6. If you move in anti-clockwise direction, this will receive 2, this may receive 5, but still, so here this is a secondary prefix, primary suffix. Primary suffix always receives more priority when compared to secondary prefix. So the correct numbering will be, this is the correct numbering will be, this is the first carbon, this is the second carbon, this is the third, this is 4, this is 5 and this is 6. So this is about order of priority. And the last one, that is when chain terminating functional group is directly attached to ring. Chain terminating functional group is directly attached to ring. For example, this is the ring system and this is a chain terminating functional group, that is aldehyde. Here you may have a doubt, what is a chain terminating functional group? Chain terminating functional group is the functional group in which three valencies of carbon are fixed. You can see when you are writing aldehyde, 1, 2, 3, three valencies are fixed. So this is only one valency is not fixed. Therefore, always this aldehyde group is at a terminal position. Even if you take a carboxylic acid, you can see here 1, 2, 3, three valencies are fixed. Even you can take ester. So three valencies are fixed. Amide, three valencies are fixed. But ketone, it is not a chain terminating functional group. It is definitely not a chain terminating functional group. When chain terminating functional group is directly attached to the ring system, in that situation we have to use special suffixes because we cannot take this carbon into the longest chain. Very clear, but this cannot be your substituent. It is no doubt it is a first grade functional group, but this carbon cannot be taken into the longest chain. In that situation you have to give numbering like this, and instead of saying normal suffix you have to use a special suffix. For example, in case of aldehyde we have to say carbaldehyde. So this is cyclohexane carbaldehyde. If you have COOH, then you have to say carboxylic acid, cyclohexane carboxylic acid. For ester it is alkyl carboxylate. For example, if you have cyclopentane ring and this is O COOCH3, then we have to say methyl cyclopentane carboxylate, not O8, carboxylate. For amide functional group we have to use carboxamide. For cyanide functional group we have to use carbonitrile. So these are the all rules and sub rules. You need to understand all the rules properly. If you can understand all the rules properly and if you practice good number of examples, you will be 100% perfect in IUPAC nomenclature. And in examples, the various examples we will discuss in the next video. Thank you very much.